Oh yeah. Wait. All right, guys. Oh. Where did it go? Here. No. How many? Right. What's yours? That's yours? All right, maybe I'll wait a minute because you guys are still looking your quiz over. So, yeah. Wait, who was just now asking me? Was it you? No. All right. So real quick, any other questions from the quiz before we get back into chapter 3? And then chapter 4, actually?
Yeah.
No, okay, good. So there was a question from 3.4. Who asked me that? Was you right? 80 on 3.4. Okay, so this is page... This is page 220. Number 80. It costs $2,000 to purchase a copier. Wow. And each copy costs 2 cents to make. So it costs $2,000 just to get the sucker, right? $2,000 for a copier.
Right.
And it costs 20 cents for each copy. Okay, and it says, what is the fixed cost? And whenever you hit a problem like this,
The fixed cost is $2,000.
they either tell you in an example, in this case they tell you in the little paragraph before the problems, right? So the fixed cost is the cost that you have to pay no matter what. So what do you pay, even if you buy it and never make a copy, you got to pay how much? $3,000. Assuming you're not going to steal that. So that $2,000 is the fixed cost. And what's the variable cost?
20 cents for 2 cents a copy.
Is it 2 or 20?
0.2.
Oh, 0.02, thanks. So it's 2 cents a copy. So that's the variable cost, of course, right? Because it depends on how many copies you make. So my variable in this case will be what? What's my variable in this case? Yeah, that's what's allowed to vary. I can make 10 copies, 1,000,000 copies, somewhere in between. So my variable cost, and you see why they call it now, so the cost is going to change depending on the situation, is 2 cents. So you can write 2 cents real quick. You can write 2 cents like that or like this. Not like this. This is 0.02 cents. They're cutting 2/100ths of a penny off.
So you
Let's not do that, yeah?
The zero.
There's 2 cents. Yeah, right, so 0.02.
But why did you say don't put 0.02 then?
$0.02 or 2 whole cents, not 0.02 cents. That's a crazy small amount of money, right? Okay. Part C is where it starts to get interesting. What's the cost equation then? And this is an example of a problem where they want you to set up your own equation, but it's just like that snow cone problem. If you go back to the snow cone problem, they already set up an equation. It's going to be exactly what we need here. My cost equals what? What do I have to pay no matter what?
$2,000.
So $2,000 plus on top of that I pay 2 cents per copy.
2 cents.
I love it. So it'll be 0.02x. It's going to multiply that. 2 cents per copy, so it's 5 copies at 10 cents. So, right?
So we set it up y equals mx plus b.
Exactly. I love it. That's the point. Right? But that's exactly it. That's the point. They want you to realize that y equals mx plus b occurs everywhere. Anytime there's a rate of something, that could be set up like this. It's sort of like you call a plumber to your house. It costs so much money to get him there and then so much per hour. So you can set up a base price plus so much per hour. It'd be that kind of an equation. Right? Call the psychic hotline. It costs so much for the first minute plus so much per each additional minute. We saw a problem like that on the first practice test. Right? And that actually came out to be mx plus b form. I didn't say it then because we hadn't talked about it, but there it was. And then part D says, what would be the cost of producing 10,000 copies? versus C, B, A, D. 10,000 copies would cost how much?
Y equals, so I gotta set it up in that equation.
Yeah, let's do Y here instead of C. But we understand Y represents cost.
Is it 0 or 0.2 and then put the 10,000?
Exactly. Where would that 10,000 go? Which variable represents number of copies? Yeah, this here represents number of copies. And this here represents total cost. So now you just have to realize where to put that 10,000. You put that 10,000 in for the X. And then just put it in your calculator. Yeah, 200, so it'd be $2,200. Cool, I like it. Here's a cool, watch this. I know you guys all have calculators and that's great. But to multiply 10,000 times 0.02, here's a cool little trick. If I move this over twice and make it 2, I move this back twice to compensate and make that 100, so that's 200. You can do that with any decimal times a whole number. You can, or actually any decimal times a decimal. You can move it over till you make a nice whole number, or just plug in your calculator. It definitely knows how to do it. But it's just good to know. It's a quick way to do that in your head. Yeah.
How do I have to put the 2,000 in the equation?
Because if you're going to tell somebody how much it's going to cost to set this up and then make 10,000 copies, if you leave the 2,000 out, you're lying. And you got to buy the copy.
Oh, okay.
So they want to know what the total cost is, period. So it's going to be your overhead. In this case, my overhead is the copier. I guess I have it sitting outside because I didn't buy a building, but oh well. Plus 20 cents for every copy. And I'm just, you know, hey, who needs copies? So weird copy dude. So now you put for this guy 2,000 plus 0.02 times 10,000 copies. And that's where the $2,200 comes from. Yeah.
Alright, so this is the only one I have trouble on the line. I think about it. It says this is on 196, number 45.
You didn't finish this, bro.
Y.
Oh. I'm sorry, real quick.
Sorry about that.
Oh, yeah, I'm sorry. There's a part E of this problem. Sorry,
It's okay. Let's go. Crap.
part E says, how many copies can you make if it costs you total $2,600? Well, where's that go now? Where's that number go? Is that the number of copies?
No.
No, it's the cost.
That's
Which one is
Y.
cost? Y. So you plug it in for Y, solve for X. I'll let you guys do that part. I did 4/5 of the problem. You guys can do the last part. I don't know if you guys see this. This kind of equation shows up all over the place. So much money to do something plus some money per something, right? Like if you rent a truck, it costs so much money plus so much money per mile. When you get a U-Haul truck, you see it all the time. Get in a cab, everything. So Wes, you had a question about?
Yeah. 45, 96, 2. So just graph each linear equation. The equation is y equals -6x.
Oh yeah, this one threw a lot of people off. They didn't say you have to use x and y intercepts, but of course I definitely would. The problem with this one, how do you get the x-intercept? For what?
So y equals 0.
Good, so make y equal to 0, so you get 0 equals -6x. So you get x equals 0, right? So the point there is 0, 0.
Yeah.
Now we talked about that before. What's going to be your y-intercept? 0, 0. That's the one point that's on both axes. And sure enough, if you find your y-intercept, to do that, what do? How do you find the y-intercept?
Yeah, x equals 0.
So that x equal to 0. So then you get y equals -6 times 0. You get y equals 0. So of course you get 0, 0. That's the one point that is on both axes. That's both intercepts at once. That sucks. What I got from people is either I got this. That's not a line. Or I got just some arbitrary, there's a line, yay. Or there's a line, or there's a line, or there's a line. It's got to be the line. It's got to be this line. There's only one line that does this. How many points do I have so far? 1. How many points do I need to graph a line? 2. How do I get a second point? Plug something in, right? Make a little XY table. I've already got 0, 0, don't I? Let's plug a 1 in. If I plug in 1 in, what do I get for y? Negative 6 times 1 is negative 6. Right, so that threw people off, and I understand a lot of people were doing every single one with x and y intercepts. You could have done every single one with xy table. They didn't tell you a specific way to do it. Intercepts are a smart way to go, unless they both are the same thing. That's not enough points to make a line. Now I've got enough points to make a line. 1, negative 6. There's my ugly little line. Right. Oh, this is page 196, section 3.2. So if you guys, some of you guys got that homework back right now, you see I've written this on a lot of your papers saying, just get 1 more point. That's all you need. 1 more point.
Yeah.
Is that cool, Wes? Or?
Yeah, so with the x and y table, you just do it on the graph, right?
Yeah, exactly. Just plug anything you wanted to for x, or y really, but here it's easier for x. And then you see now you got 2 points. Yeah. Yeah.
I don't get 48 if there's a y equals 3. What happens to the x?
Yeah, what happens? If I have an equation, and remember those are 2 special cases, but I really want you guys to get this, and I said this before, but let me make sure you guys can get this. I know this is not what we're talking about, but let me build up to that, right? If I have y plus x equals 4, give me 1 point that works.
0. 0.
0, 4, okay, that makes sense. Give me another one, like 1 what?
3.
1, 3.
2.
Thanks for playing. 2, 2. 8, negative 4, right? Anything that adds up to 4. And if you graph those, it'll be a straight line. Because this is a direct relationship between y and x. You'll see that when you graph it, right? So this one says x can't be really anything if y is something, and y can't be anything if x is something. They relate to each other. So the minute I call x 0, y better be 4. The minute I call y 2, x better be 2. They can't totally do whatever they want to, right? If I know one, the other one's set. So what does this equation leave out, like you said? That equation leaves x out. Does x have to do anything then? Specific. X can do whatever the hell it wants to. Y can't be anything except 3. That's what that says. So give me some points that work here. What's got to be here?
3.
3. Y's got to be 3. Does it say anything about x? No. So x can be whatever you want it to be. If x is 7 and y is always 3, what's y? 3. So it's sort of silly. It's sort of like saying, okay, I'm 39. I just turned 39. Like, this is the first time I said that out loud. It kind of sounds. You guys are like, I remember 39. If I said, okay, I'm 39, well, I'm going to stand here. Now how old am I?
Still 3.
30.
And I'm going to turn around. How old, So it's like saying y is 3. No matter what x does, y is 3. You can't change it. So what would that end up looking like then? You can actually, if you just graph these, they give me a little easier one. 0, 3 is where? Yeah, there's 0, 3. Where's 1, 3? 1, 3, right? So is it going to be, it's just a straight. Why does it make sense that it doesn't go up or down? Because the minute you try to go up or down, what changes? The y-axis, the y does, right? And y can't change. It's got to be 3. So if it was an x equals something, what would that line look like? Straight up and down, yeah, vertical. Because then x can't change. It's got to be set, right?
So for that problem, we could plug anything in for x.
Anything you want to, exactly.
And the same goes for that problem as well.
This problem's the same idea, except now if you change x, y cares. Over here, if you change x, does y care? No, y's 3. It says, oh, I don't care what you're doing, x. X says, oh, what now? I don't care, I'm 3. Right? Okay.
Quick one. Number 27, page 218.
218?
It's figure 3.4.
So 27. Oh, cool. Perfect. This actually comes right off of what we just talked about. So this is one of those write the equation of the line problems, right?
Yeah.
And it says, write the equation of the line
It's supposed to be slope intercept. You don't have enough information.
that has undefined slope and goes through 0, -2. This is number 27, page 219,
Yeah.
Yeah.
218, 3.4.
3.4.
Is it 218?
Starts on 2. The weird thing here is, if you try to force it, this is what I was saying earlier, if you try to force it into this, what will you put there? Slope is undefined.
Yeah.
What would you put there then?
0.
It's
It's
not 0.
undefined.
0 is defined.
Undefined.
It's undefined. So don't force it into that. It's a special case. If it's slope 0 or slope undefined, it's a special case. If it's undefined slope, which one of those is it? This one or that one? Is it vertical? Careful, that would be 0 slope, flat, right?
Undefined is vertical.
The wall.
The wall, I love
Wall.
it. Undefined slope is the wall.
Yeah.
What kind of line is that? Like it's vertical. It goes to the point 0, -2, and it's got to be straight up and down. So one way to say it is the y-axis, but I want an equation. If it's straight up and down, is it x equals or y equals?
X equals y.
So x equals 0. The equation must be x equals 0. Right? If it was a
Yeah, I know. I got it right. I just.
if it was a flat line, if it was slope 0 through 0, -2, what would that be? Y equals -2.
Yeah.
Because a flat line is y equals something. Straight up and down line is x equals something, like we just talked about, right? So what if x is 0 at this point, and x has always got to be the same damn thing, x must be 0 everywhere, right? If y is -2 here and is always going to be the same damn thing, if they would have said a horizontal line, then the equation would have been y equal -2. So it's when you try to force those special cases into this that it freaks the hell out,
Yeah.
right? Yeah.
I have a question.
All right, is everybody cool with that first? Before?
So the answer is just simply x equals 0.
That's the answer, exactly. Yeah. Because it doesn't care what y is. It's straight up and down. Y can do whatever it wants to. X must be 0 though. Okay.
Homework. 3.1, 74. 74 and 78.
74. So we talked about that problem before, the snow cones problem. Right, and that's like the easier, the one that we just did with the packing the paper. So real quick, 74 was a snow cone problem, and they said if 100 snow cones are made, you get $5,050. And here's the equation.
What page is this?
Page 185, section 3.1. We talked about this problem before, though. What's the x variable represent in this equation? Number of snow cones, and the y is the cost. You see that almost all the time, because your input should be the number of things I want to make, and the output should be cost. So, well, if I make 20, how much money is it going to cost? And that's what I want to know. So how do I make a point? I always make a point x comma y. X represents, like you just told me, x represents number of snow cones. So in this case, what goes in there then? 100. Comma cost. 50/50. 5,050. That's the cost. And the next part of that problem is the same problem. They just give you 200 snow cones. Right? So you make this point the same way. They just ask you to make a point out of it. Right?
That's it, just that's the point.
Just the point. That's all they want. Cool. 78 is just plug those points in. Right? Do you answer about 78?
Yeah, this one?
What about?
Yeah.
This is 74.
Yeah.
Right? So part B is the same thing. Same idea. 78, you just plug those ages in for the right variable, right? That was the heartbeat problem.
Yeah.
In that case, X was the age. So if they say 20 years old, that 20 should go in for X. Don't forget to graph that problem. So you guys turn in homework and there's no graph. They ask you to graph that problem. Do it. All right, so any other questions? Okay, cool. So last time, believe it or not, because I'm going to do section 3.6, that's going to be the last section we do, because it's sort of like the very first stuff you do in the next level of math, these functions. So 3.6 we're not going to do yet. We're going to do that towards the end of the class. So we did finish up chapter 3. We got up to 3.5, and then we even did 4.1.
Yes,
Even if you weren't here, we still did it. Exactly.
So more notes on 4.1.
Oh yeah.
Oh.
What's really weird to me is I teach a class known as basically Calculus 3. And the funny thing is, we were talking about system of equations today and there. You can imagine that their equations are probably a little better. But I want you to realize it's the same freaking idea. It holds throughout all of mathematics, what we're doing right now. So it's not just specific to Math 90. It's something you're learning now that will be used everywhere after this. It could be, right? So systems of equations. Yes, ma'am.
So we end at 4.1.
I think last time we basically finished 4.1, so we're just doing a little review, and then we're going to do 4.2 and 4.3, and possibly 4.4. We'll see.
How do you do the short form of equation? Remember?
Oh, equation was like that.
Okay.
Thank you, because I almost did that earlier. I couldn't remember I said that. All right, so everybody just deep breath. We'll be all right.
So this ends.
A lot of these sections are actually, they used to be one section. 4.1, 2, 3 used to be one section because they all deal with how to solve a system of equations. There are three main ways. The first way we talked about was graphically. So a visual way to get the answer. The next two will be an algebraic way. All right, so let's do a little review of how to do it graphically. I'll give you a problem that will explain why the hell graphically is not good enough. That's why we need to have some other way to do it. So to solve a system of equations, what does a system of equations look like? It looks like this, for example. Well, let me do it like that. Yeah. I'm going to show you again the suggestion I made last time about how to graph this so that you can make sure you're going to catch the right place. I just want to check. Okay, this is why from chapter 3, I desperately need you to be able to do this relatively quickly, graph this. You shouldn't need to make an XY table. You shouldn't need to find the intercepts or whatever. You should just be able to tell me how to graph this straight from what this says, because it's already in the right form, right?
Right.
They're not always going to be that way, but just solve for one. What do I know about this line?
It's 0.4, right?
Good. The y-intercept is 0.4.
And the slope is 2.1.
So 0.4, and the slope says go,
Up 2 over 1, right?
I like it, up 2 over 1. Now I'm going to, if I went up 2 and over 1 again, up 2 over 1, I'd be about right there. Right? Does anybody remember, let me see if you guys, well, let me do this. Let me just stop there, because that's basically what we did last time. Remember my suggestion was to count more than you normally would, so then it's easier to see where those points are. Because the whole point here is you try to see where these lines meet. And if you just draw a line, they're going to meet like in a weird place. You want to be more specific. You want to give yourself more anchor points so you can see where these things are meeting. So this line looks like this. And that's line number 1. In fact, when you do,
But we only have to do 1.
what do you mean?
We only have to go up 2 over 1.
Maybe not. That's my point with this problem. I made this problem a certain way. So how do I graph number 2? What's the y-intercept is 0, 1. And it tells me to go
Yeah.
down 1 over 1, right?
Yep.
Down 1 over 1. Well, where are they going to meet then? Over here. But watch what I can do for myself. I didn't go that way, did I?
Nope.
Let me see if you guys remember how to do this. If it's 2 over 1, how can I go backwards? Negative 2 over negative 1. You guys remember that? If I can go up 2 over 1, I better be able to go down 2, back 1. And there you go. Now I can see where they're meeting better. Pretend like it's straight. So sometimes you're going to have to count backwards. If they're going to meet back here, they're going to meet somewhere back there. You're going to want to be able to count over it and then up and back. You're going to want to be able to get back there so you can see what the hell's going on. And just to double check, if this is down 1 over 1, it's also the same thing as up 1, back 1. Here's the thing, I don't want you guys getting stuck with the words. Negative 1 over 1, isn't that not the same thing as 1 divided by negative 1? Aren't they the same number? But when I look at it slope-wise, math says it's the same freaking number slope. What the hell's your deal? But slope says, shit, that tells me to go up 1, back 1. And that's where they meet. They meet right there. Cool. And I could tell that better because I took one and I took the other one, and I can see that's exactly the point where they meet.
It's the same thing, no matter which negative you go.
Exactly.
Just one of them has to be negative.
Exactly. Good. So what point do they meet at? What is this point? Negative 1, 2. X, Y, right? What does that mean about that point again? What's special about the point besides that's where they meet? I mean, what's that mean? What's that mean about this point? What must that point do?
Must be that.
It's got to work in both of these, exactly. So that's how you check yourself. What is twice, let me take my negatives out of here that I put it in. What is twice negative 1? If you put a negative 1 in for X, negative 2 plus 4 is 2. Check. That's not good enough though, they got to work in both. What's negative negative 1? 1 plus 1? 2. There you go. That is the point that works in both. Right? Because when I draw one line, that's all the points that work in that equation. When I draw another line, that's all the points that work in that equation. So which point works in both equations? The one that's in both lines, right? It only makes sense. It only makes sense. That's my hope. And my dream. Okay. Can somebody imagine then? Oh, Jeff.
Well, we plugged in, I think I heard you say, we just plug that into that to make sure it's right.
Mm-hmm.
Yeah, the X and the Y.
That's just a check. And just to remind you guys, if you do this, that's not good enough. That's not the answer. I'm not going to look it up for you and count. No, you give me the point. The answer to a system of equations is a point. You better see that point somewhere. Okay. All right. So here, you guys do this one real quick. Oh, let's see what we're doing now. Okay. Whoa. Okay. It's not crazy. Wow. That's anything I did. Oh, sure. You guys are making your own thing up anyway.
That's not 11 in there.
Oh, yes, I did. I just felt the need.
If we want to make this,
Second.
if we want to make the second line white blue, do we have to do that first? We don't have to.
It's a graph that what form does it have to be in to see all the information? Y equals mx, so you gotta get y by itself first. Good. suggest you do. This is pretty much how to see it on the paper too. I want to see some scale to it. Actually, it should work.
We gotta put all the numbers.
Huh? Because I needed to. I had to make it work. You guys, are you noticing something as you're doing this? What are you noticing? Though they definitely cross.
But you have to take a really large lot of points to find the big.
Exactly, yeah. Right? So let's do this one at a time here. In fact, let me see if we're on the same page with this one. So y equals 2x minus 1 when you solve for y. Cool. So that's the first equation. Second one, you just add the 4x over. Right? So when you start doing this, on the first one, what's the y-intercept?
0, -1.
0, -1, I love it. And then the slope tells me to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. You can do it, Jeff? That might be enough. Of course, everything's sideways when I do this. Okay. You don't necessarily know when you first do this how far you're going to have to go, but when you start graphing the other line, you might want to go, oh crap, let me go back to my first line and count further over, because it looks like you're going to meet somewhere further. Well, my question, well, we'll see what happens. What about the second line? What do you know about that?
Y is
Beautiful. And the slope tells me to go, oh, let me do this in beautiful. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Oops. Yeah. Stay with me now. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Hey, is that right? Looks like it's trying to meet there.
Yeah, it's trying. So,
4, 8.
So what point is that we met at?
it's either 3, 4, 3, 5. My graph sucks. I don't have graph paper.
What point is that where they met?
5, 9.
5, 9. Right? You guys see that? So where am I losing you guys?
I think it's just because they don't have graph paper, so it's hard.
Could be. So this is a good reason to get some graph paper,
Yeah.
right?
Yeah, when they get that big.
You can actually, you can go online and Google image and just type in graph paper.
Who needs graph
You can
paper?
print it out.
Right here.
Wes is a good man. He's got some graph
Boy,
paper.
Wes.
I'm not that generous.
Thank you, brother.
Does anyone else want?
Sweet. Look at that.
Nice guy.
I wanna have a little bit.
So what if you sent it to negative one, you would go back one, and still go forward one?
Careful now. That -1 is the what?
There you go.
The slope. I mean, it's y-intercept.
Y-intercept. That's why I went to 0, -1.
Oh, so you just.
The slope is up 2 over 1, right?
Yeah, never mind, okay.
Cool. Okay.
So how do you think the over one?
So -1, and then up 2 over 1, up 2 over 1, so forth. So even if you don't know to go that far and you draw this line, you're like, holy crap, that's going to meet somewhere way over there. Let me come back to the first line and be more specific and count more with my slope. This is not going to happen very often in your homework. Don't freak out. Most of the time it's going to be, close to 0 where they meet. Because we're trying to make it semi-easy, right? But I mean, they can meet, really, technically, they can meet at a freaking 80. Which by itself is enough reason to not only know how to graph them, to know how to do it algebraically. How do I check this again real quick? So if I plug in a 5, 5 to the 4 is 20 minus 11 is? 20 minus 11 is 9, right? That's 0.59. If I plug in a 5 here, twice 5 is 10, minus 1 is 9. There you go. So I know I'm right. Right? It's a good idea. It's a good thing that I know how to check that. It's cool.
Will there be problems where you plug in one, they'll work in one line?
If you find this and you did everything correct, it has to work in both. But if it doesn't work in one of them, that tells you graphed something wrong. You went the wrong way on the slope or something, right? It's just like checking an equation. If it doesn't work,